Can you see my slides?
Can see.
Okay. So hello, my name is Hui Ting, and I'll be talking about my implementation of the robot programming project. So here I have two BBC diagrams. One is for following the trail, and another one is to inside the open field. So in each of these states, each behavior is started as a process because I'm using multiprocessing. And then the sensors are read into, the sensor values are also a process which can be used to feed into the behaviors. And then there is an arbiter as a process as well to determine the actions of the robot. So my implementation of the broken trail is to use the camera. When there is a broken trail detected, the camera will capture the image in front of it to see if there is a black region. So if there is a black region, then that means the line is not complete yet, so it will move forward until the end of the line where it cannot see the black region anymore, so it will stop. To get from the trail to the open field, there are two states. One is the border detection and the other one is the field detection. So for the border detection, it will go from the trail to the border by first detecting the border. So if the border is not detected yet, it will just keep on moving forward until the border is detected, then it will stop. Then when it's at the border, it will start the field detection. So when the field is detected, it will stop. Otherwise, it will keep moving forward. Then to roam the field, there are 4 behaviors that influences this behavior. The first is cliff avoidance. The second is obstacle avoidance. The third is find object. And the fourth is roaming the field randomly. But the primary driver of the roaming behavior is roam field, which every 4th second it will rotate left, and every 9 seconds it will rotate right. Otherwise, it will keep moving straight. Then to look for the obstacles and goal, I use the IR sensors and the ping sensors. So if the IR sensors are triggered, for example, the right one is triggered, then it will turn right towards the object. And if the left IR sensor is triggered, then it will turn left towards the object. And if the ping sensor detects that there is an object within 15 centimeters, then it will just move straight towards the object. So to deal with the obstacle versus goal, I'm using the camera to see the colors of the obstacles and the goal. So if the camera senses a black or green color, it is determined to be an obstacle, so it will turn away. And if the color is yellow, it will just push the object. Then to count the goal and decide its completion, I'm using IR sensors, ping sensor, and camera to determine whether a goal has been pushed off the cliff. So when it's pushed, the IR sensors, the ping sensor, and the bottom IR sensors will be active. And then after that, I will announce the number of goals pushed. It acts as a buffer to prevent the same goal from being counted again. There is an extra feature which I will explain later that counts the goal beforehand. So this can be used to compare with the current number of goals being pushed to decide the completion of the task. So for the interesting features, I have LED lights. So in the follow trail state,
Somehow we lost your, I can't hear your sound. It's quiet.
Can you hear me?
It's okay now.
Okay.
I'm
I'm
using
using my phone audio, so I don't know if there's feedback.
If you off your PC's mic, should be fine. I think you can, yeah, mute. But right now I don't hear problem. Try.
Can you hear me now?
Can hear.
Okay. So the interesting features are the LED lights. When it follows the line in the follow trail state, it's green, and when it detects a broken trail, it's yellow, and when it detects an animal, it's red. And then for in the open field state, these are the colors which will be which represents the behavior that is currently active in the robot. Another interesting feature is avoid pushing the goal in the direction of an obstacle. So here I'm using the difference in height to aid the camera to see the obstacle behind the goal. So if there is an obstacle detected behind the goal, it will just turn away instead of pushing the goal. Next is the counting of obstacle and goals. So before the robot roams the field, I take a picture every 15 degrees by using the pan servo and the camera. And then all of the images will be stitched to create a panorama image. And this image will be used to mask the goal and obstacles by its HSV ranges. And then these masked objects can then be used to count the number of goals and obstacles. So with this information of the number of goal counted, the number of goal pushed, and the number of obstacles counted, I can use this information to announce this information in the end, because I'm using timeout as well as the number of goal push to determine the end of the task. So if the program times out before the number of goal is equal to the number of goal count, then this can be used to determine that the robot hasn't actually pushed all of the goal. I'll be showing my demo. Can you hear it now?
Yep, I can hear.
Okay, so that's the end of my presentation. Thank you.